So I was asked to do voiceover videos, and as I'm currently not planning any new experiment or didn't really do anything which isn't uploaded to YouTube already, I thought I'd just take some of the videos I really liked from the previous series and yeah, kind of give some further explanations or backgrounds to the experiments themselves because the space in the text box for YouTube is just so limited that I can just give a brief explanation, but I can't really talk about the backgrounds of the experiments. So I'll start with one as a test, which is probably not going to be uploaded to YouTube, and then I'll see how I plan them. So also note this is just made up randomly because I didn't have really time to look through the videos, and yeah, this was just the first one that popped up on my list. I thought, yeah, I'll give some basic explanations. So this was a video I really liked. It was the formation of iodocyane. Iodocyane, a combination of iodine and cyanide. I'm not very sure if this has a real name. Iodocyane. It's called bromocyane, chlorocyane. So is it iodocyane? I think it's iodocyane, iodocyane, whatever. Yeah. So usually this compound is made thermally. I think Chemplay did a video on it, which is where I got inspired. I think I talked to Chemplay before, and we talked about the problems they had. I'm not really sure about the iodine compound. I know something about the chlorine and bromine compound, which quite often polymerizes or forms cyanuric bromide, cyanuric chloride, I think. So they kind of form different products. The reason for this is also quite interesting. It has to do with the way how they polymerize. I think I just saved this for a later video. It's just some basics in cyanide chemistry. Cyanide can either do a CC coupling, which is I think base catalyzed, and it can do a CN coupling, which is acid catalyzed. So you often end up with a ring where you're having like a benzene ring, but alternating C and N atoms in the ring, which is called, I think, triazine. Not sure. And this is where all your cyanuric compounds come from. They come from this CN polymerization. Well, the CC polymerization goes into endless dimensions. Besides the thing with 4 C's, because once it reaches 4 C's, it has a mesomeric structure, which is more stable if it forms. So you always get a black mass plus transparent crystals of the C4 compound. And I think, or I predict in a similar manner, these halogen substituted cyanides react and polymerize up. I think they just lead to the same type of products. But I'd have to check this out. So yeah, what we're starting with here is a solution of very few crystals of iodine. I think I just had the spatula in the bottle of iodine and then dipped it into a solution of hexane because yeah, hexane dissolves this stuff so well. And I really like this. I like this purple color of the compound. It's something I really demand from students often. I remember when I was in my second semester studying chemistry, we had this analytical lab, and we had to find out ions in solutions and in solid samples. And quite often people would come to me and would ask me, how did you find iodine? We did a lot of stuff. For bromine, we can smell it. For chlorine, we can see it. For fluorine, well, we can make HF, or yeah, iron fluoro complexes. But for iodine, we can't really see much. I mean, there's the experiment with starch, but we didn't have starch in the lab, and somebody would have had to buy some or get some. And then you also have to cook it and boil it before, so nobody really took the time to do it. And so they often just guessed it was iodine because it smelled like a halogen, but it didn't form really a gas. I don't know why they didn't try to heat it. Not my problem. But I often told them, why don't you use hexane or heptane? And they didn't know that it formed different colors once it's dissolved, which is, I think I have a video on this on YouTube as well. So I often demanded this when people came to me and they said, is this iron? As I go back, add some heptane, check if the heptane layer turns purple, and if so, you know it's iodine. I won't give you further information unless you try this, because I wanted people to really remember this type of reaction. If you look for my channel, you see that every time we have iodides or iodine in there and iodine is formed or is used, I'm using heptane to show it. It's a very nice way to show that iodine as an element is present. So yeah, as I said, I talked to Ken Player about this thermal way of making iodocyane, and I made this before. I remember I distilled it once off and I kept it in an ampule, and it polymerized and my white needles were all gone. So I knew if I wanted to show on YouTube that a reaction happens, I needed to change it somehow. And this is why I decided to try whether the reaction would take place in solution as well. So I knew I had to mix an iodine solution with cyanide. I could have taken some in ethanol to have it in one layer, but I thought it would be more impressive if I did this in 2 layers. So what you can see here is the layer of heptane, I think it was heptane, with iodine dissolved in it. And what I'm adding here, and I think I can let a video play right now, what I'm adding here, yeah, there it is. This stuff is just dissolved potassium cyanide, and I think it was quite concentrated solution of potassium cyanide. So yeah, as I mix them, you see the water layer and the heptane or hexane layer, whatever it was, they don't really mix, and you also see that the iodine doesn't really go that much into the aqueous layer, because it doesn't really dissolve well in water unless there is some iodide in there forming polyiodides. And yeah, what we expect by this reaction is, or what I expected is, as it reacts, it forms the colorless compound, which is in either of these layers. I'm not sure if it dissolves in water and in hexane, but it doesn't matter. And yeah, as it reacts with the iodine, it should become colorless eventually. So I wasn't sure how to treat this. Should I stir it up? Should I fairly mix it up? And I thought, yeah, I need these 2 layers to mix as well as possible. So at the end, I decided to really shake it. You see, at the beginning, I'm just twisting it. I'm trying to create a vortex in it. But this will just push one of the layers to the outside of the glass walls, and the other one will stay in the center, so it doesn't really mix. And you can see I shake it, nothing happens. But then I start shaking in a different manner, which is now, I start shaking in a different manner so they really mix, and you can see how the color really vanishes. And I didn't expect this to happen. I had no idea it was going to happen. Yeah, I just expected the iodocyane to form, because I'm not sure which product might form besides this one. At least the iodine is reacting. You can see it should react with the cyanide, and it became pretty much colorless. So whatever compound formed, you can see that it happened after it reacted with the cyanide. You can also try this with water. I don't think much is happening if you just add pure water. There's nothing doing redox chemistry with it. And it formed some product, and I thought this was a very nice way to really show a reaction. And this is basically what I try to do in my YouTube channel and all my videos. I take things that you could find in books and analytical books and things you need to find out ions in solution and in solid compounds and in substances and whatever. And if they're colored, it's okay, I can bring them onto YouTube. If a side product is set to form, like iodine or selenium or something like that, I try to find stuff like suitable solvents or reactions that really show that it forms, because I cannot do any different thing. I can barely show you gases being produced unless they're colored. I cannot tell you that the smell is changing. So I really need colors. And I think this iodine plus hexane or heptane is just a very beautiful way, especially in this two-layer system, where you really can see how one layer changes as the other layer has something in it as you mix them, but they don't really mix. You can see that if we did this in ethanol, for example, you know, if side products form, they might react with the ethanolic solution of iodide, with iodine, whatever. There are just too many side reactions that could happen, and of course, yeah, it's just more beautiful to do this with this purple compound than with the brown or yellow compound, which also leaves stains. You also have polyiodides in solution, which might not react that way, and I think this way was just beautiful to show. Yeah, I hope I could give you some backgrounds in how much time you really have to take to plan these videos, from a basic idea, knowing that a compound might form, up to a way to show it, to make it more beautiful, to show the reaction. And then you need to try it out. I mean, this could have been a reaction which takes like an hour or a day to do. Then I wouldn't have been able to film it. So I was surprised it worked. I just started shaking it and it discolored. I think if it took more than 5 minutes, I would have stopped. So yeah, I'm really happy this experiment really turned out the way I wanted it to be. I think it turned out even better than I expected it. I did it with bromine, as you can see in a different video, and it just is beautiful. You know, I can't do it with chlorine because you don't see chlorine. I could have chlorine bubble through it if you like to see that, but nothing would eventually happen. I don't know, maybe we can try, maybe we can see if the chlorocyane reacts the same way with transition metal ions. So maybe that if there's no cyanide present anymore, you don't see a reaction. But I fear the chlorine might also oxidize the cyanide to cyanide somehow. So there are side reactions possible. Yeah, so this was just the very first video, and I think we're already at 12-13 minutes. I don't want to take this, don't want to have this all too long. Yeah, just tell me what you think about these videos. And I will try to make further videos which have more information in it, because I don't really want to talk about too much about the background, but I want to show you how you can use these experiments in different ways. I mean, this is nothing you can do that often. There are different ways to test for iodine than putting cyanide in it. But we will see some reactions that can be used for more than one sample, for more than one ion, like iron thiocyanate, where I'm testing iron and thiocyanate and fluoride, and you can also test cobalt with it and extract it with alcohols. There are different ways how you can develop these reactions, how you can take these into the next step, to the next level. And this was, yeah, pretty much what I could do with voice videos, because I think most of the explanations are better in the text box below, where you can really read through them, where they're summarized. And I'd do some videos with voiceovers where I can just give some further explanations. So yeah, thanks.